Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com webinar, brought to you by TechStrong, AWS, and Rafe Systems. My name is Cody J. Brown. I'm the host of TechStrong Learning, and we have an exciting presentation for you today. First, I have a couple of housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session. If you have any questions, we want you to send those in using the Q&A tab, which can be found on the right side of your screen. It's also where you're going to find the chat tab, and that's where we want you to speak with one another, speak with us, let us know your thoughts throughout today's program. And finally, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around till the end. So our topic today is how Fortune 500 companies leverage Kubernetes and AWS to accelerate app modernization. And I'm joined by Haseeb Budani, founder and CEO of Rafe Systems, Nate Tabor, product and developer advocate for Amazon Web Services, and Santosh Pasula, head of site reliability engineering at MassMutual. Haseeb, Nate, Santosh, thank you all so much for being here. Haseeb, are you going to take it from here?
I will. Thank you, Cody. Nice to talk to you again. Appreciate the session being set up. Thank you, everybody, for joining. I have, two personalities on this session today who I speak with a lot. I've learned a lot from them, different things, and I'm looking forward to having a fun conversation with both of them. Let's actually do a real introduction from their perspective. Gentlemen, if I may impose on you to introduce yourself. Santosh, we'll start with you.
Thank you, Haseeb, and it's great seeing you again. Thanks for having me on this webinar. My name is Santosh Pasula, and I'm a technology executive with 25 years of experience, out of which I spent more than 2 decades of my career in financial and insurance technologies, supporting various applications, infrastructure, and whatnot. Pretty much creating and running IT shops in financial and insurance industries. Currently, I'm heading the site reliability engineering for public and private clouds at MassMutual. And my background, I would definitely call myself an engineer with a business hat on. My educational background includes, bachelor's in computer science, and I have a master's program in information security and privacy. And I also have a business degree. I have an MBA in innovation and growth strategies. Thank you.
Thank you, Santosh. Really appreciate you making the time. And Mr. Tabor, how are you? And tell us what you do at AWS.
Hey, nice to meet you, everybody on the call. And Haseeb, great to speak to you again. Santosh, same here. Really nice to see you guys today. And I'm really honored to be able to be here and have a conversation about Kubernetes and AWS and all the great stuff that both Rafe and MassMutual are doing. I'm Nate Tabor, and I lead product management and developer advocacy for Amazon Elastic Kubernetes services. So our team helps to manage all the different Kubernetes offerings from AWS, including the managed services that we run, but also all the open source and Kubernetes upstream contributions that AWS participates in and helps move. And I've been at AWS for I think about 5 years now. I would say I'm the opposite of Santosh. I'm a business person with an engineering hat on, and been leading technical teams here for the last 5 years at AWS, and really been working most of that time on building our Kubernetes practice and making it really easy for customers who want to use Kubernetes to use AWS with Kubernetes and to really accelerate their ability to bring software to their customers and to their internal teams and make it easier for them to actually modernize their business processes, do less operational overhead work, and move a lot faster when it comes to delivering value for the organization. So really excited to talk to you both and share a little bit about the work that we've been doing at AWS and kind of how we see the world in terms of what our customers need to go really fast with Kubernetes and with modern application architectures.
Great. Thank you very much, Nate. And by the way, folks, my name is Haseeb. I am part of a company named Rafe. Rafe is a Kubernetes operations platform provider that enterprise use to speed up their consumption and truly governance and standardization for Kubernetes platforms such as EKS. So we have enough customers who use Rafa with EKS today, which is why, of course, we spend a lot of time with Nate and team. But today we're going to focus on, as Santosh says, taking enterprises from hello world to real world. So I love that phrase. Santosh uses that, and I'm stealing it. So Santosh, let's start with you, my friend. So keeping that hello world to real world concept in mind, maybe we start with the basics, right? So the Kubernetes it's not easy, right? It's a complex system, right? We all know this. It's okay, right? So how did you come about, the decision that MassMutual should use Kubernetes, and how did you go about making the decision around the right platform for the business?
Yeah, so that's my favorite quote, right? How did we move from hello world to real world, especially in containerization, keeping it as a core of our cloud strategy. So at MassMutual, containerization is not new. So containerization, we started our journey with Docker and Docker Swarm, and eventually moved towards Kubernetes. Docker Swarm was great. It's an easy to use and simple solution, to manage your containers at a particular scale. And especially if the company is moving to the container world and does not have complex workloads to manage, then Docker Swarm worked great. And that's purely my opinion, right? So now eventually that journey was successful, but when you are trying to bring in your crown jewel applications or more and more complications towards cloud, this is where we had to rethink our strategy. And especially when we're dealing with applications that are tricky in nature and more complex, and if you're looking for a complete package, let's say that includes satisfying your monitoring needs, satisfying your security features, and at the same time self-healing capabilities, high availability, and if we are also talking about throwing this absolute flexibility into the mix, right? So that's when Kubernetes is the right choice, and this made us lean towards Kubernetes.
Excellent. So you are an Amazon EKS user. At some point, did you as a group consider, I don't know, maybe running your own Kubernetes control plane on top of EC2, or how did that play out for you?
Well, yeah, I think we are digging some details here. Actually, we tried that. We tried that in the past and ran into multiple practical issues, right? So especially when you have your standardization and optimization, right, in the cloud operations world, if you have these two as the core of your cloud strategy, this is where we ran into challenges. Sure, we can go ahead and create an EC2 and then get Kubernetes on top of EC2 and try to manage Kubernetes on your own, right? Now the cluster creation, maintaining hygiene, fleet management, vulnerability management, AMI lifecycle management, I can throw a lot more into this mix. So these are the areas where we definitely ran into some practical issues. And we decided to use or to leverage EKS as the Kubernetes solution. Number one, the cluster creation and maintaining hygiene is a breeze compared to where we started in the past, where we don't have to maintain everything from scratch. And at the same time, we're working on fleet management and vulnerability management is at the at the core of our business, right? So whether we're talking about financial or insurance products, your vulnerability management has to go hand in hand along with your cloud strategy. And obviously there's AMI lifecycle management that's involved, and these are the areas where we kind of leaned towards EKS, especially with AWS right at the core of the cloud strategy. In fact, we are migrating our workloads from legacy custom Kubernetes solutions that we built in the past to EKS. And this is helping us to take the advantage of the level of abstraction that EKS is providing.
Interesting. So I'd love to ask Nate the same question. So Nate, look, Kubernetes, it's open source, arguably folks can run them themselves. what are you guys doing differently that's getting, Santosh and, teams like his to choose EKS? What's so special?
Yeah, I think Santosh said it really well. It's going from hello world to real world. And Kubernetes is Kubernetes is actually like, I absolutely love Kubernetes. It's an amazing system. So many of the workflows and patterns when you're using Kubernetes just make sense, and they actually make life a lot easier. And the complexity of Kubernetes, I think, comes in two places. It comes when you're getting it all set up. Kubernetes is a very much a kind of an open box model, right? Like you have a lot of basic stuff that gets shipped along, but there's a lot of decisions you have to make when you go from run a really basic, let me run a basic web app on Nginx, and then moving that out into, okay, let's actually run production applications, running the kind of stuff that Santosh is running at MassMutual. It's a totally different world, and you need to have, governance, security, observability, networking, there's a whole bunch of things you have to layer on top of Kubernetes. And so one of the things that companies love about Kubernetes is this open architecture. But one of the things that also makes it really hard to kind of get started if you don't have a need for something that's that open, right? Or that, that's so, that's not so opinionated, I would say. It's less opinionation. And so that's the first place where customers struggle. And then the second place where they struggle is actually like scaling Kubernetes into production. So starting a Kubernetes cluster, especially on EC2, is a relatively straightforward task. There's a lot of community work, some great work with tools like kubeadm and kops that let you get a cluster up and running in a few commands. And that all goes really, really well until you actually run into some of the production use cases that our customers run into. Like, I want to scale a cluster, over 1,000 nodes. I want to actually run 2,000, 3,000 nodes on this cluster. I need to do a version upgrade. How do I upgrade API server and etcd? If you've ever done an etcd backup, restore, and upgrade workflow, let me tell you, that is like, yeah, Santosh is nodding. These are really hard, tricky things. Going from a single API server configuration where you have like one API server and one etcd state store, bringing that into a production highly available configuration. These things take a lot of effort. They take a lot of operational expertise and a lot of time. And that's the heavy lifting that EKS is taking off of our customers. So our goal is to bring complete Kubernetes clusters that customers can then take advantage of, and do that in a way that respects both the open source and the open architecture of Kubernetes. So what that means on the open source side is that we run vanilla upstream Kubernetes. So you should get with EKS the same Kubernetes experience that you would get if you ran Kubernetes on your own. Just the difference is that you don't have to carry the pager and be responsible for all the operations and the maintenance of the control plane. But that's it. Like we're bringing you the same upstream vanilla Kubernetes. And the second thing is that we believe that it's really valuable for customers if we bring AWS opinion in terms of operations and different layers that you can use in the cluster, but that we maintain that open optionality of using or not using those things. So in addition to managing the Kubernetes control plane, we also have APIs that help manage the lifecycle of the nodes, the EC2 instances. We have a managed EC2 set of APIs, and we also have a serverless set of APIs for running serverless nodes on Kubernetes. And then we also are moving forward and introducing new APIs that help to layer in and manage the lifecycle of the operational tools on the cluster. So for things like networking and observability and security. And what's great is that all these APIs work together. So you can have a single thing and say, hey, give me a production ready cluster, and have that go up and have that be managed, all that infrastructure be managed by Amazon. Or you could say, look, I just want the control plane. I'm going to do everything else myself. And that all works. Those are all valid options. So those are the two things, is like taking the operational burden off of customers as they go into production, so they can focus on managing their applications and not the infrastructure. Maintaining that open source, not just compatibility, but like complete alignment with the open source project. And then also bringing in layers of opinion that help customers automate parts of their Kubernetes cluster management but bringing those in as optional layers that they can easily use or decide to do things themselves if they prefer.
Excellent. I think it's worth digging into the some of the design choices you've made around their security scalability, and I think we should get to that. But to kind of set the stage for that, I think we've been talking about Kubernetes in some ways we've been talking about a cluster, right? But the reality is, in a big enterprise, nobody's got a single cluster. Nobody's got one or two or three clusters either, right? In fact, I remember, by the way, many years ago now, when we first started working on this concept at Rafe, I had a bunch of conversations with people who would say things like, well, look, we have three clusters and we have one prod cluster and one dev cluster and one, stage clusters, and I think we're done, right? But the world hasn't played out that way. In fact, Santosh, in your case, right, you have so many internal customers, and you use the word fleet, Santosh, right, in your prior response, right? Talk a little bit more about that. What is a fleet, and why do you need a fleet? Why don't you only have three clusters?
So piggybacking on what Nate was mentioning, right? 1,000 clusters. Eventually, it might sound a lot when you start this journey, but trust me, you will get there faster than you can realize. And when we are dealing with a large set of infrastructure like this, mostly virtualized, and how do we manage it, right? So that whole management aspect will soon become a nightmare for the IT operations or the cloud operations team. And this is where the fleet management aspect comes into picture, right? So when you are talking about managing thousands of parts and how do I push an update? Or let's say there is a 0-day exploit that just happened. We all went through the journey of log4js, right? So what happened with log4j in December, and all of a sudden it became like a fire drill for the companies to go fix it, right? So those are the areas where fleet management will come into picture, where I try to make an update in one image and try to push that image across the board, so that way the teams are not sweating on working hundreds of parts, but eventually you have you have to have this mechanism where if your infrastructure is taking advantage of the elastic nature of the cloud, which obviously I think is the number one reason why most of the companies move to cloud. And management of these resources within the cloud is going to be a nightmare, and that's where fleet management comes into picture, in my opinion.
Okay, and as you kind of think about a fleet, from a strategic perspective, in a product conversation you and I've had, you've used this phrase landing zones. So in fact, I was just kind of recalling a conversation we had, maybe the first time when I spoke about this concept called landing zones. I think it's worth defining it for other enterprises who want to get to where you are. Could you talk about that a little bit? What is a landing zone, and how do you use it?
So landing zone, in a nutshell, is a hardened cloud account that we create for our customers. And in an ideal situation, you'll have someone knocking your door, saying, "Hey, I want to move to cloud," and obviously, tell me what does it take to move to a cloud? And the first thing that you do is you create an account. So landing zone, in our opinion, is technically infrastructure as a code pipeline, IAC pipeline. So we leverage Terraform a lot, and eventually what we are doing there is we are creating an account for a business unit where the business unit can bring their workloads and start integrating their applications. But however, this account is special. In what way is it special? Is this is pretty much a standardized and optimized account, right? So you're technically building the swim lanes for this business unit, and establishing these guardrails, making sure your cybersecurity partners are aligned, with your strategy. And then as part of this, there's an RBAC model that kicks in on, what kind of access do you want to give it to your developers versus your SREs, and how do we play all these things, right? So that's where the landing zone comes into picture. And since we are discussing the Kubernetes topic here, in fact, we made good progress in the last 1 year or so, and today we are we are offering Kubernetes as part of standard offering when someone asks for a landing zone. If you are my customer and you'll say, hey, I have these 10 applications, I need to run in cloud, right? So the first thing that we do is, okay, here's your landing zone, and here's your Kubernetes cluster, here's your infrastructure that you need for CI/CD pipeline, and here's the standard SDLC that we define, right? So development, non-prod, and production. So development is your playground where you can go put all your pieces of puzzle together to make sure your application is working, your application is deployed and working, and then we deal with two CI/CD pipelines, as we say. One is for infrastructure as a code. So when you're talking about your readiness to move to a QA environment or a production environment, right? So you don't have to go rebuild all those resources. So for that, we build a Terraform, and using the Terraform pipeline, we just migrate the Terraform to non-prod and production. So your resources are actually spun up and waiting for you before your applications make their way into non-prod and production. This is one of the pipeline that we build, and the second pipeline, obviously, our application partners own it, which is application-specific pipeline, right? So this whole magic was possible, and obviously the stepping stone for this is the landing zone for within public cloud.
Excellent. I think
I hope I answered your question.
Yeah, no, totally. I think I appreciate you saying what you said, because this is exactly the point I wanted to make. One trend here, that we see at Roth is companies trying to, standardize to a point where essentially I can, essentially execute a pipeline, and it just builds all of these things for your internal customer, right? And that's the nirvana that people are looking for. And it's all the governance and all the standardization already built in. And I do want to make sure I come back to that. But we're talking in terms of MassMutual. Nate, I'd love your thoughts on, are you seeing this play out in other major accounts that are using EKS, or what's your kind of view of the kind of broader market? Is Santosh on the cutting edge? Is he sort of, in the top of the curve? Where is he as far as you see it?
Oh, that's just, you're really setting me up here, Haseeb. I would say Santosh is exemplifying the best practices that we see from a lot of our enterprise customers, right? Especially in the Fortune 500, Fortune 1000. This is exactly how they're using Kubernetes, and this is exactly how they should be using Kubernetes and EKS. It's building a platform using EKS, using AWS, building a platform, and then exposing that out to their internal customers and saying, here's your new environment, go and build in it. And I really like that you brought up the Log4j CVE that we had in the fall. That was huge across a lot of companies. That was not AWS specific by any means, right? That was industry wide. AWS had things patched in, I think it was about a week. EKS was certainly patched in under a week, and there's a lot of clusters that EKS is running. And for customers like MassMutual and others, being able to rely on a partner like AWS and having our team that works 24/7, when that kind of thing happens, we go to work and we make sure that all the infrastructure is patched, that all the control planes are patched, that everything's ready to go. We also released, for example, a daemon set that took an agent that our Linux team developed really rapidly, which would actually block this attack, right? And you could install that on every single host until you had actually updated your Java in order to mitigate the Log4j attack. And if you put this on, it would provide an interrupt that would disrupt that attack if it had happened on the nodes. So that's the kind of stuff where we can quickly patch all the control infrastructure. All the managed Kubernetes clusters can be patched at the control layer by AWS within a matter of days. And in these types of incidents as well, when we know about them ahead of time, we do our best to actually have them resolved ahead of time as well. So there's many incidents where customers are notified sort of after the fact. And the absolute best security incident response for us is a message that says, hey, by the way, we learned of this 0-day that was non-public a few weeks ago, and it's already taken care of. That's the best message I think customers like Santosh can receive, and that's the goal that our team takes. And then when things are emergent, we get it ready as fast as possible. And so when an organization like Santosh's team is worrying, is faced with this kind of situation, they can know, hey, look, at least part of this, at least this whole Kubernetes control infrastructure is handled, and we just have to focus on our applications. And AWS is giving us support and tools as we go, but it's just taking a huge amount of work off of people's plates, right? And so that's a big thing that's a big lift that we try to bring for customers. That's a really important part of our mission. And then I would say, as far as this pattern of like taking Kubernetes, building in that opinion for Mass Mutual, saying this is I really like what you said, like here's the run book, here's how you deploy your applications, here's your CI/CD pipeline, here's the managed Kubernetes environment, now you're ready to go run your applications. That's exactly the pattern that we're seeing, and that's one of the reasons why customers are adopting Kubernetes, right? Because you have this standardization in terms of tools and runtime that you can use, and easily deploy that across all of your properties and all of your teams.
Awesome. Yeah, and so, I might throw another quote in the mix, right? So, well, one of my other favorites, right? So, changing tires on a car while the car is moving. So, that's exactly.
Yeah. So I think one action for me after this call is I need to get T-shirts, two sets of T-shirts published. One is, of course, we gotta have the from Hello World to Real World T-shirt, right? We gotta have one of those T-shirts, and the other one being changing tires while the car is moving. I will take that action. Nate, you said something that, I mean, there's a bunch of customers using EKS, right? And all of them have lots of clusters. I mean, this is a really big task. Talk a little bit about how you give your, high-end customers, the Fortune 1000s, comfort that you've got their back, right? What have you done from a security and scalability perspective? And by the way, it sounds like the audience here is quite technical, so feel free to dig as deep as you want. I think you also had a slide for this, but talk a little bit more about that. What exactly have we done that is special?
Yeah, I mean, this is really what AWS does, right? Like, this is what we're particularly good at, is running infrastructure at scale, and our operations practice is very well developed here. So, and that's what we're doing with EKS, right? So we're taking the best practices. I don't know if folks have probably seen this architecture before. This is what a EKS cluster looks like on our side. This is kind of our view of a cluster, right? We're taking all the best practices that we've learned over the last 20 years at AWS in terms of how do you run distributed systems at scale for customers, and we're applying those to EKS, right? Like, so we don't run EKS any differently than we would run services like EC2 or VPC or RDS, right? So we're taking all those learnings, all those best practices from Amazon, and we're just applying them to Kubernetes. It's not magic. It's just what we do every single day at AWS. So the first thing to look at here is the architecture, and so this is a snapshot of a single cluster. When you run an EKS cluster, you're getting a dedicated VPC on the AWS side, so VPC that we operate. You're getting multiple scaling groups where we're running distributed API server nodes across 2 AZs, where every EKS cluster runs across at least 3 AZs. We're running 2 API server nodes. These are dedicated EC2 instances for the cluster on our side. We're also running at least 3 etcd nodes as well. So we're establishing an etcd quorum across multiple AZs. And this protects us to a very, very high degree of failure. So EKS offers a 99.95% service level agreement right now for the availability of the Kubernetes control plane. That's a really important thing for customers, so they can count on that availability. And we're starting from this highly available architecture. What you're not seeing is there's a whole bunch of other operational practices that I can't actually show here, but I can talk a little bit about them. And it starts from things like our practice of cellular architectures, right? So a lot of our customers follow this practice as well. And it's a practice that we follow at AWS, where we actually divide things into multiple AWS accounts. So we spread things across availability zones, across regions, across accounts. And even on the AWS side, there isn't some single AWS internal account where you can find all the AWS stuff all running together. It doesn't look like that. We shard everything out. And this is all about reducing blast radius, right? On the operations side, where we're spreading things out in lots of ways, and we're integrating really deep operations in terms of automated alarming, automated monitoring, automated actions that kind of keep infrastructure healthy, And we do things that kind of ensure that the cluster is always available. And we have a lot of SLOs and SLAs that are being watched, and kind of really best practices in terms of like, how do you run production infrastructure at scale? One of the things that we've done more recently that's, I think, really interesting about EKS, if you look at this diagram, you'll see we have these 5 nodes that are supporting the cluster control plane. And you'll see there's these auto-scaling groups, right, in these nodes. And when EKS first started out, we would kind of just pick a size and we would run that. And that worked relatively well until customers got really, really big. And then they would say, hey, I'm running 4,000 nodes on this cluster and my performance is a little bit laggy, and we'd have to go in there and like manually adjust the cluster to make it run at scale. As EKS has grown, and doing that has, really became not possible for the number of customers we had to support, we've introduced backend infrastructure that actually looks at the load on the Kubernetes control plane and dynamically resizes the etcd and API server instances. So we're doing vertical scaling of the backend, as well as doing tuning of the control plane flags. So there's a number of Kubernetes flags that you can tune. We really want to get into details. It's things like max requests and flights or QPS. These are different flags that people will tune on the control plane. And when you set these correctly to match the size and the load of the cluster, you can really improve the latency and the performance of the cluster as you scale. And so from a product perspective, what that looks like is, as a customer, I can load this thing up. I can come in, I can start 1,000 nodes, I can run a big web server. If I have a big spike, the control plane is just eating that up. And you should see really low latency and really high performance all throughout the scaling ladder. On our side, it looks like a very complex set of automation where we're scaling the backend, we're tuning the cluster dynamically, we're monitoring all that operationally. It's all sharded out across multiple accounts, multiple regions, multiple AZs. Teams are auditing that and looking at that. We're doing things like complete human access management, where it's not possible for operators to manually touch these Kubernetes clusters. If an operator ends up manually touching a cluster, for example, alerts are sent to people, right? So it's completely hands-off, completely secure and locked down. So there's a high degree of redundancy, of security, of automated reliability that's going on the team. And so those are the kind of things that we're doing on our end. And that's like, this is not easy stuff, right? I mean, we've been at this since 2018 or 2017, actually, at this point. So almost 5 years we've been working on building this system out. And so, our hope is that customers who want to adopt Kubernetes say, hey, that is awesome. We love that. We love that we can get all this operational best practice, all this heavy lifting that's been done by AWS. We can also get the pure vanilla upstream Kubernetes, and we don't have to worry about this stuff. We don't have to learn about how to adjust max requests in flight when we go from 500 nodes to 5,000 nodes. We can just rely on EKS to provide us a highly available control plane. And so that's the first thing that we're doing, is managing that backend for customers. The second thing that we're doing is we've built a number of integrations with other AWS services, and this is kind of an ongoing strategy for us, I would say. And we think that AWS has a lot of these really awesome higher level services. EMR is a good example of one for Spark jobs and for machine learning and data science. And we're actually making it possible for these services to run workloads on EKS clusters. And so we have an EMR integration where you can use EMR to run Spark jobs on EKS clusters. And we're also doing integrations with services like GuardDuty, which allow you to have real-time threat analysis and security analytics for your Kubernetes audit logs. And there's a number of other integrations that we're working on that will be coming as well. I think Systems Manager now integrates with EKS. So this is the second thing that we're doing. It's running really solid production-ready Kubernetes clusters, and then it's giving customers those really deep integrations to higher level AWS services, so that when you bring Kubernetes to AWS, you can also take advantage of that those higher level capabilities while still using Kubernetes as your core.
Right, and Nate, that's a very good use case that you brought up, right? So Amazon EMR, and obviously we're not going to dig deep into this, but another day I'll make one comment here. Especially if you're running your data science frameworks or data management frameworks on EMR, I think the level of abstraction that we are getting here is incredible, right? I mean, if you think about it in a practical world, customers like or users like me could actually go concentrate on the business aspect of it, on the data science workloads aspect of it, rather than managing the different layers that are completely abstracted out for me, right? So that's the biggest advantage that I see in this use case.
Yeah, absolutely. And we're also going down, right? Like that's the other thing that we're doing is there's I kind of think about it as bottoms up and tops down, right? So we have the core, which we talked about for Kubernetes. There's also let me bring these higher level services onto EKS, and I agree that it's having that level of abstraction where you know what's going on underneath, but you can also just engage, and your teams can engage at the layer where it makes sense to them. And then the other thing is, can I use Kubernetes to then take advantage of the underlying AWS infrastructure? Can I use the Kubernetes API to manage AWS? And that's kind of the next level for a lot of folks as well. And why does this matter? Well, a lot of applications need things like data buckets, like an S3 bucket or a database. And a lot of our customers were like, okay, I have the Kubernetes cluster, I have my Kubernetes app, and then I need an S3 bucket that goes along with that. That's a really big hassle for me to go through another set of APIs, set that up, and then try to cross-link those together. So this is the other integration layer that we're working on with EKS, is that we call this project ACK. And this allows you to use the Kubernetes APIs to actually instantiate and manage the lifecycle of AWS resources to complement the cluster. So if you need to an S3 bucket or a DynamoDB, instance that will connect and be used with your application in Kubernetes, you can actually instantiate that through a Kubernetes CRD and dynamically link it to your application, so that your application can use those things and that they can use them as they scale. So this is the other layer of integration that we're doing. So I think that's really our job, right, is to provide all these building blocks and make it so that companies like MassMutual can take advantage of those building blocks and build really quickly without having to worry about how do they set up and manage all this infrastructure to get their applications into production.
Yeah, amazing. Yeah, I would say one nugget that I would recommend everybody take from that conversation and beyond the integrations is so you kind of said the phrase, cell-based architecture, so cellular. This is a really important thing that I would say anybody relying on anything SaaS, right? Anything delivered as a service, right? I think it's an important question to ask your vendor, right? Are you running cellular, cell-based architecture? And if they're not, it's really important to understand, right? When is it not going to work for you, right? Because if they're not already, and if a vendor running a SaaS service is selling to large enterprises and they haven't really thought about, cell-based architecture for their platform, at some point it's not going to work, right? So of course, and I actually don't know if the concept of cell-based architecture was created at Amazon or not, I have no idea. But we certainly use it, and we certainly have learned a lot from, well, I think actually at some point, I believe we also spent time with your team, right, on that cell-based architecture review, right? So that's something that just as an aside, everybody should think about. Make sure you're asking your SaaS vendors, are you investing in cell-based architectures or not? If they're not, ask them why. What is their scaling strategy? But with that, I want to turn to something that we have sort of touched on, but haven't spent too much time on, and I think it's really important, right? Because we use the word standard or standardization multiple times, and that also brings up the other word governance, which Santosh, you've said a couple of times as you were talking about other things, right? So you have these clusters. Okay, we know that they're rock solid. EKS is great. It seems to work. 99.995, 3.5 nines is what makes that, right? But then how do you make sure the enterprise expectations of what configuration looks like, what governance means to you, who has access to what, how does that play out? And firstly, how much of that do you care about today, right? And to what extent have you taken steps to address those requirements?
Well, that's a loaded question, in my opinion. I'll try to answer it in a few minutes, right? So First of all, container as a service, the buzzword that we use a lot, especially what we call CAS here. So CAS is it's really at the core of the cloud strategy, right? And obviously Kubernetes is a big part of cloud computing, and the reason why we align towards Kubernetes and Rafe in general is the wide variety of out of the box features, allowing companies to manage their consumer demands, and which are mostly elastic in nature. And eventually, before we realize this can get pretty messy, right? If it's not properly planned and managed. And we talked about thousands of containers. We talked about how we route the traffic to these containers and high availability aspects, as Nate was mentioning. And there's load balancing aspect, there's high availability aspect. How do you distribute your network traffic? And at the same time, your BCP plans. How do you manage your business continuity planning or disaster recovery aspects? Right? So all those things will fall into place when we are talking about the real world application, right? And there are certain industry standards, regulations that we have to play well within, and meet the audit requirements from IT point of view. In general, governance is a big deal, especially if you're talking about financial and insurance organizations. It's a big deal, and we'll have to establish these guardrails, predefined guardrails as per your security policy requirements, and we have to play well within these guardrails. And now, if we dig into the implementation aspect of it, yeah, sure. There's cluster provisioning, there's management of clusters, and how do you handle it? You probably use like standard spec files and your GitOps pipeline. Obviously Rafe added GitOps as well, as one of the offering, the product, right? So all these things will ensure we are playing within the predefined guardrails. And when we talk about cluster lifecycle management, right? So that's spec file driven as well. And with GitOps sync features, we have built the ability to fix critical vulnerabilities quickly and perform routine AMI upgrades, right? Now the question comes back to how do you differentiate access patterns between, there's a developer community, there's an application support team community, there's site reliability engineering community, and few others, right? So implementing a standard RBAC model is very important, and that has to be done before you move from POC to pilot, right? And POC is like, proof of concept, proof of technology, that works great. But end of the day, when you pick that pilot application, I think your RBAC model should be carefully vetted out and implemented starting with the pilot application. Now this is where you'll define pretty much the roles on who is going to own the cluster provisioning, who owns the lifecycle management aspect of it, and who owns the namespaces that are running within the clusters, right? So all these things will be part of the the standard RBAC model. And today, an Eks cluster provisioning is a standard offering as part of the landing zone creation, as I mentioned a few minutes back. For any business unit that knocks the door, we'll give a landing zone, we'll give an Eks cluster that is provisioned through Rafe, right? And I have to thank Rafe and the CAS teams on our side as well, because they literally worked hand in hand to set up these automations, and both for provisioning as well as governance implementations, right? And this eventually has made us the Kubernetes offering that we standardize today. So all these efforts, I can probably summarize this in 5 minutes, but there is a tremendous work that went into the scene behind the backgrounds, and there are multiple teams involved, multiple obviously companies involved here, and this is what is guaranteeing us that we are meeting our IT audit requirements, we are playing well within the guardrails, and making sure that we are delivering the applications as well, right? Because businesses have to go, and honestly, if I put my business hat in, if I'm a business unit owner, I don't really care about whether my workload is running in Kubernetes or my workload is running in some XYZ, right? But I definitely care about it if my application is not performing well, right? So it's a perfect balance that you need to maintain between your governance and at the same time not compromising the performance of applications.
Well, firstly, thank you very much for the plug. I appreciate it. It's been, of course, a pleasure to work with your organization over the last year or so, as we've kind of made significant progress as a team, I would say, right? I mean, it's truly a joint effort across 3 companies to make any one, a large organization successful. Maybe I'll ask one more question on that same front, right? So we haven't really, we've been talking about clusters, and we mentioned this thing called applications. We've talked about automation for clusters. What's your perspective on automation for the application layer? Like, I don't mean the add-ons, right? That's maybe part of your team's charter anyway, but your internal customers, right? What is your advice to them in terms of, the level of automation that they should be aspiring to? GitOps, whatever you're, basically kind of giving them as guidance.
I'll also throw another buzzword into this equation, right? So blueprints and the whole blueprint management for EKS fleet, right? Now deploying enterprise approved and governed blueprints. What we do here is like, we have an SRE cluster, and that's really our test cluster, right? So whenever you have changes to the blueprint or a new blueprint is created, we deploy it on SRE cluster, and then we test it out, and we have our own testing mechanism where we test it out. And then when it is ready to share, that's when we share it, across the fleet. And this definitely enables organizations, right, to follow the standard approved SDLC lifecycle and the release cadence, and that's a whole different topic. We're not going to dig deep into that, but at the same time, SDLC lifecycle and release cadence is followed for all the blueprints, right? So that's what we're ensuring here. I'll throw you few examples at a high level. If you have changes to your ALBs, right, or if there's a secret management aspect of it, something is changed in there, and as a matter of fact, if you have certain monitoring requirements that you're introducing, right, as part of this change. So those are the areas where blueprint management comes into picture. And at the same time, our motto here is to see that all clusters that we are spinning, they're configured in the same way and they're managed in the same way to the extent that's possible. There are always exceptions. No matter how much planning you do, there will be exceptions. But at the same time, our goal here is to stick to that at least 90-10 rule, right? So 90% of it is standardized and the 10% are exceptions. And those are the things that we deal with. And not on a daily basis, but frequently. And at the same time, your blueprints are vetted out and they are tested before they're deployed to the fleet, which ensures security, compliance, and the whole application functionality that is not compromised.
Excellent. So there's a lot of thinking going on at like the center of excellence level as to what does this blueprint look like, what are all the add-ons, what are the versions, and then you're sort of creating a standard and then rolling them out, across the fleet in some sort of an automated fashion using GitOps. Is that a fair summary?
That's a fair summary. Yep.
Yeah, I mean, I said that in 10 seconds, but man, that's a lot of work, right? So actually getting that right, as I think all of us on this call know, man, that is not an easy task. Recently, EKS also announced this kind of framework called Blueprints, right? Which, of course, Rafe is a part of that announcement also. Would you mind, just kind of describing, because our friend Satoshi brought up the word blueprints, right? What is your perspective of blueprints and how do you think about it, right?
Well, I think blueprints is less of a, I think like Rafe has blueprints, we have the EKS blueprints thing. I would say blueprints is becoming more of a pattern than it's a blueprint. It's a pattern more than it is like a product per se, right? Like different people are going to have different products, different ways of implementing this. But I think the high level is that customers need. I mentioned earlier. I said this very quickly that EKS. Our goal is to provide a set of building blocks. And that's actually that's not an EKS thing. That's an AWS strategy, right? Like if anyone's looked at the product menu on the AWS homepage lately or in the console, if you haven't looked there lately, it's an eye chart, right? Like there are a lot of things, and Kubernetes doesn't make that easier. There's like 200 AWS services, and then you come into Kubernetes, and there's like 40 different Kubernetes APIs that are standard, and that's just like the tip of the iceberg. There's thousands of projects out there that you can layer into Kubernetes. And so the scope is massive. And the question that customers have, and I think this is what Santosh was talking about, is like, okay, I need to actually put this into production. How do I put all these things together? And there's decisions they need to make both from the central team, right? Like, which is like, which pieces of software should we use? How should we configure all this stuff as a best practice? And then going down to an app team, how do I actually give that app team a reliable, repeatable way to implement this best practice that we've spent a lot of time researching and figuring out? And so that's where blueprints come in, right? So from the EKS side, we're kind of trying to give customers an example of what implementing a pattern like this might look like. Like here's some Terraform or CDK of like what it looks like to bring a whole cluster together on EKS and put it into production. So I wouldn't categorize EKS blueprints as a product per se. It's a little bit productized. It's more of an example that shows you how to put things together. Rafai's actually taken that a step further and kind of really built this idea into the product and made it really well integrated. That makes it easy for you to kind of template out these different clusters and deploy them. I think that's awesome, by the way. And so I think that these are two different things. One is kind of like an open source example that helps customers kind of get aligned with how to actually put this into production. Where the and then the what Rafai has done is actually built this best practice of how do teams like MassMutual, how should a team distribute and make sure all their developers are aligned and all their dev teams are aligned, and that's really built the product in. How do we template these things out? But I think this is all solving that core problem that Kubernetes is a wonderful. One of the things that makes Kubernetes amazing is also one of the things that makes it hard to go into production. And the idea of templating and blueprinting really helps to wrangle that issue. So it's absolutely something that we build toward and something that we support. I'm really excited that we have the EKS blueprints. And also, I think the work that Rafai has done here is really awesome.
Well, you heard it here first, team. Nate Tabor says Rafai is awesome. But the way I think about this from our perspective is, truly Kubernetes is a double-edged sword, right? But it's actually a really, really practical utility. And what Rafai is trying to do is blunt one edge of the sword, not both, one, right? So you can actually use it and not hurt yourself, right? That's at least how I think about the problem. We're getting to the top of the hour, and my friend Cody's kind of reminded me of the time here. Maybe this is a good time to start wrapping this session up. I think, look, I had a list of 15, 16 questions. I actually got through 3 of them. So I got through 20% of the questions I had because the conversation flowed quite well. But at this point, if I may impose on you, Santosh and Nate both, and I'll start with Nate first, as you see the market, please, if you could, just opine a little bit on, what are your recommendations for best practices, the things that we haven't talked about maybe today, and the things that you worry about, mistakes people are making, just, any high-level guidance that you can give from the AWS lens, that would be great. And Santosh, I'll invite you to do the same right after. Nate?
High-level guidance. It depends on what you're thinking about, right? Like if you're trying to decide, should I use a managed service like EKS, or should I, go my own and roll my own Kubernetes? I would say either one is fine. And actually, I didn't get into it, but we built a ton of stuff at AWS that helps customers take advantage of AWS, even if they're running their own Kubernetes. But I would think about it in terms of like, what are the core competencies of your organization? What do you want to be good at? Is it a good competency to be an expert at operating the Kubernetes control plane? a lot of our customers say that's not what we're here to do. We're here to actually like, build the business applications or build the SaaS that's going to move our business forward. And we need to rely on partners to move that quickly. And so that's the question that I often ask customers to ask themselves is like, what do you want your core competency to be? And if the core competency is managing and operating infrastructure, like that's great. And for some of our customers it is. And they've spent significant time and effort building this stuff out. For many customers, it's like, look, that's not a great use of our resources. We have limited development bandwidth. We have limited time. Let's use as much as we can to go far and go fast. So that was my advice, is you kind of look to make these decisions. And then I would say, I'll give the advice that I give to my team at AWS for making these types of product decisions, which is identify your one-way and two-way doors. Right, like so that this is a concept that we use at Amazon a lot, which is think about what's a decision that can be easily reversed, and what's a decision that once you walk through that door, it's very, very, very difficult to walk it back. And so at Amazon, we spend a lot of time identifying one-way and two-way doors with the idea that if most things are two-way doors, most decisions can be easily reversed and you can go the other way. And so if this is a two-way door decision, move fast. Take advantage of managed services, take advantage of managed infrastructure. Your concern may be very valid 5-10 years down the line, but can it be handled 5-10 years down the line? In that case, are you going to spend months or years building perfect infrastructure or building a system yourself from scratch? Now, when you could build on a framework like Kubernetes, where if you ever wanted to do that in the future, you could do that, but then you can actually get so much farther with delivering value for the business. So I would say, think about those things as you select vendors, as you select tools and systems and things to go on top. What's a two-way door decision? What's a one-way door decision? How can you make a one-way door decision a two-way door decision? And when you do that, how can you remove obstacles to moving quickly on the organization, so that you can get the value and you can get to your goal a lot faster. So that would be my high level advice, and I think that applies to CTOs and folks like Santosh at MassMutual, and it's also the advice that I give my product management team here at AWS.
So you've talked about things like, in terms of just nuggets that I'm collecting from this call, hello world to real world, one-way doors or two-way doors. My God, forget Kubernetes. I'm just in terms of just, just concepts, I'm learning a lot on this call today. But if I may give the, yeah, we gotta get this trademark, my friend, right? Just so we can make some money on this. But yeah, if we may, end this conversation, Santosh, with you talking about just your advice to your peers out there. Please, if you could, talk about what do you think they should be doing or not doing as they make their journeys kind of move forward with Kubernetes.
Yeah, and I have to mention, this is my favorite question so far, right? And I'm going to wear my business hat for a minute here.
Well, so the rest were not, is what you're saying, right? So the rest was not a fun conversation.
Or pardon me, right? It's my most favorite. Let's put it that way. So I'll answer it with the business hat on. And nowadays, the customer satisfaction is really in the rear view mirror, right? What I meant by that is, it's expected as part of the standard. Customer satisfaction is no longer a privilege. It has to be done, as part of the standard. However, the way you're going to change, you're going to stay above your competition is through a customer delight factor, as I would call it. And Kubernetes plays a very key role in the customer delight aspect of it, if you're thinking about it from an IT perspective, right? Where we are increasing your velocity or reducing your complexities in IT operations, right? So these are the things where the customer delight aspect comes into picture. How fast you can roll out your changes right from development to production. And at the same time, how stable and reliable your IT solutions are, right? So this is where Kubernetes can play a key role if it is planned out well. And one advice that I would definitely give to other folks is, always think about your customer when designing solutions around your Kubernetes deployments. And again, your customer might not care whether you're using Kubernetes or Docker or some other technology, but they will definitely care if your application is failing or not performing well, right? And Kubernetes in general is very exciting technology stack, and I totally agree. It's a double-edged sword. Now, keeping your standardization and optimization goals, as part of the core principles of your container as a service strategy. That's very important. At the same time, spend enough time during your POC. Don't just do the hello worlds, but think beyond the hello worlds. And at the same time, picking up that pilot application is very important. And spend enough time during your POC and pilot stages before you start bringing your crown jewel workloads onto the Kubernetes platforms. Yeah.
Excellent. So very practical advice. Don't just kind of be happy with the basic test and say, okay, I have my answer. Take it seriously. Really think about the final answer, of course, before you bring on your crown jewels, as you said. This was a fascinating conversation. I hope the audience, the biggest takeaway for me is, look, firstly, yes, Kubernetes is hard, but organizations such as MassMutual, which is a very large organization, they've truly done this at scale, right? They've done this in a highly governed fashion, in a secure fashion, and I think many enterprises out there who struggle with this, perhaps, right? I mean, there is a path here. There's clearly a path. Santosh has done it for sure, and then others have done it as well. And maybe to that point, Santosh and Nate, if I may ask you, if folks who are listening today or may listen afterwards, if they want to reach out to you and talk to you about some of the things you talked about today, where can they find you online?
That LinkedIn is my favorite platform, and I'm available on LinkedIn. I have an app on my phone, so I probably check LinkedIn every single day. You can find me on LinkedIn, and feel free to reach out. It's always great and fascinating to have these conversations, and I really enjoyed this conversation, right? So hopefully we'll do more of this in the future.
Yeah, absolutely. Nate, how about you?
Yeah, I'm the same way. LinkedIn, big LinkedIn user. You can also find me on CNCF or Kubernetes Slack. So if you want to Slack me on CNCF or Kubernetes Slack, you can look me up there. I am a reluctant participant on the fringes of tech Twitter. So if you are a big Twitter user, I'm somewhat there, though not as much as on Slack or LinkedIn.
Excellent. Well, great. Thank you again, both. I appreciate it. And now I'll turn this back to our host, Cody.
Well, Haseeb, thank you. And Nate and Santosh, thank you as well for joining us today. I'd like to remind our audience that this session was recorded. So if you joined us late, maybe you missed some, or you'd just like to rewatch, you should be receiving an email with a link to access that recording on demand. But you can also find it living on the Container Journal website at containerjournal.com/webinars, and be sure to look in the on-demand section. So we do still have 4 $25 Amazon gift cards to give out. Our first winner is Fani G. Our second winner is JK. Our third winner is Melanie H. And our fourth and final winner is Brian K. So to 4 of you, congratulations. Keep an eye on your inbox to claim your gift card. But if you don't happen to see that email, please check your spam folder. So I would like to thank AWS and Rotbase Systems for sponsoring today's webinar. And to our audience, we really appreciate you joining us here as well. We ask for 1 extra moment of your time to fill out a brief post-webinar survey that will pop up on your screen here in just a moment. But otherwise, we do hope to see you at an upcoming TechStrong Learning webinar or workshop. Everyone, have a great rest of your day. And Haseeb, Nate, and Santosh, thank you one more time.
Thank you.
Thank you. Bye, team.
Thank you all.